We're going to look at the breadth-first graph traversal algorithm. The way this algorithm works is that it starts from a node and explores all the neighbor nodes before moving on to the next level of nodes. So we're going to show an example of this using the graph that you can see here, starting at node D. From node D, we will visit node A and E, so we can consider this to be the level 1 nodes. Then from here, we visit node B, which we can consider to be a level 2 node. Finally, we can visit C and F. So in this way, you can see the order in which the nodes have been visited. Now, the first time a node is visited is via the shortest path from the starting node. So a typical application of the breadth-first traversal is for determining the shortest path of an unweighted graph. We are going to trace the breadth-first algorithm, but before we do so, it's worth just investigating the code. Now, we are going to use the graph in the top right hand here. This is the graph we're going to traverse. And then we have the corresponding adjacency list underneath. And if you look at line 12 of the code, you will see that adjacency list in the form of a dictionary. Then on line 14, what we'll do is we'll make a call to our breadth first traversal procedure, starting at node A. Now inside that procedure, we create an empty queue. We enqueue the current node. So in this case, this is going to be A. And then we also indicate that it's been visited by adding to the visited list. Then we enter the while loop. Now, the way this while loop works is that as long as we have nodes that haven't been visited, we will be inside this while loop. So once we've visited all our nodes, then we will pop out of this while loop. So we'll have completed everything in the while loop. So we go into our while loop. Our list is not empty. And so then we dequeue the first value on there, which in this case is A at the moment. And then we print that out. And then for each of the adjacent nodes, we visit those. We check to see if they've been visited beforehand. If they have, then we add them to the, if we have, then we ignore them. We ignore steps 10 and 11. But if we haven't visited that node before, what we do is we append it to the queue and we append it to the visited list. And we keep doing this until all our nodes have been visited. Let's begin tracing our code. So we're going to start on line 13. And the first thing we do is we create a list called visited. The list is completely empty to begin with. Next, we make a call to breadth first traversal. And you'll notice that we are starting at node A. We create an empty queue. We append our node A to the queue. And we append our node A to the visited list. We've also changed the color of our node from red to white on the graph to indicate that we have visited A. We then enter our while loop. So at the moment, the queue is not empty and we'll remain in this while loop until the queue becomes empty at this point. Next stage is to dequeue the first value. Then we output that value. And then from A, we are going to visit the nodes which are adjacent to it, which is B and D. So visiting D first, We then check to see if we have visited D, which we haven't. So we're now going to add D to our queue and add D to our visited list. Next, we look at the next adjacent node from A, which is B. We check to see if it's been visited, which it hasn't, so therefore we need to execute lines 10 and 11. We add B to our queue and we add B to our visited list. Go back to line 5. The queue is still not empty. There's two elements in there, D and B. We pop the first value from our queue, which is D. We output that value. And then for each of the adjacent nodes to D, we check to see, we go through it and we check to see if they've been visited. So we look at this, check to see if it's been visited. And you can see in this case that A has already been visited, so we're not going to execute lines 10 and 11. Now we take the next adjacent value, which is E. E has not been visited. We add E to the queue. We add E to the visited list. At this point, I'm going to stop because it's going to take some time to completely trace all of the code here, to completely trace the whole graph. But I hope this has given an indication of how to trace this code and how the breadth first traversal code works. What you can do now is see if you can continue tracing this code and see if you can get the same output for the code, the tracing table, as we have on the right hand side.